We're going to take a look at simplifying this rational expression here. When looking at this, it looks pretty intimidating. It looks very scary. We have this complex fraction of 1 over 4x plus 4, and then all this lot in this denominator. Like, there's a lot going on. So first thing I would just jump off at was factoring that. I would just factor that, and then hopefully something nice will happen. So let's check it out. Let's go ahead and factor the bottom. So I'm going to have 1 over x plus 4 all over 1 over, so then x squared minus 2x minus 24. We're looking for two numbers that multiply to negative 24 and add up to negative 2. So you just got to go through your combinations of numbers that multiply to 24. So we know it's going to be some combination of 6 and 4, because that's how you get to 2. But now we just got to figure out which one's positive, which one's negative. So if I do negative 6 times 4, that's negative 24. Then negative 6 plus 4 is negative 2. So that's my combination. So it's going to be x minus 6 and x plus 4. And it wouldn't be the worst idea to like look at your other terms just to see, is this problem going to help us out with something? Because typically there would be some sort of help where once you factor, it's like the other terms. So you use that as a guide. I'm not saying that's always going to happen, but it's nice when it does. So we have 1 over x minus 6. So now we want to eliminate all of these fractions. So in order to do that, we're going to multiply by the LCD, which in this case is going to be x minus 6 times x plus 4. So I'm going to multiply everything on the bottom by that. Let me actually, it's over here. I'm going to multiply the bottom by that. So x minus 6 times x plus 4. And there's actually multiple ways to do this problem, but this is just always the way that I always go about it. And then I'm going to multiply the top by x minus 6 times x plus 4. So on the bottom, I'm distributing this whole entire binomial times the binomial to here, and distributing it to here. And then on top, I'm multiplying this times just that. So nothing too complicated happens on top. On top, let me move this down. On top, I'll end up with just x minus 6, because the x plus 4s will cancel out, leaving me with x minus 6 times 1, which is x minus 6. Over. Then on bottom, when I multiply this to here, everything cancels completely, right? Because it's x minus 6 times x plus 4 times 1 over x minus 6 times x plus 4. So the x plus 4s will cancel out, the x minus 6s will cancel out, leaving us with just 1. On the far side, when I multiply this all the way over here, this is going to be x minus 6 times x plus 4 times 1 over x minus 6. The common error here is like, some people will think like, well, I multiply this to here and they canceled out, so therefore like that term's, that multiple is completely gone. Like then I'll just be left with 1 over x minus 6. Like no, it's being applied to both. It's this times this. Or sorry, I didn't know if I pointed that out correctly. It's this, and then you got to multiply that. So over here on the far side, the x minus 6s will cancel this time. So I'm just left with x plus 4 times 1, which is just x plus 4. So 1 over x plus 4. And if this was like, let's say 2, you would do 2 times x plus 4. Or if it was like another variable like y, you do y times x plus 4. So no, whatever that term is, you're going to multiply it. But in this case, since it's just 1, we really don't have to worry about it a whole lot. So then on top, I'm left with x minus 6 over, I have like terms of 1 plus 4 is 5, so x plus 5. And there it is. There is that term simplified. And there's some restrictions where x cannot equal 6, because if you got 6 here, 6 minus 6 is 0, so that would cause some issues in the denominator. But since things are going to clean up, though, it's not. Usually, I don't focus on the values of that it can't be, but you know, we're just trying to simplify here. And I just want to. I think I counted for everything. Okay, so that was the simplified. So the main focus here is simplifying that.